looking at today, so what we're covering today is going to be surface area. Surface area. So we're talking about three-dimensional shapes, and the surface area is going to be the area of all the different faces, all the sides combined. Now there's a few shapes that we'll look at, and one of them is right prisms. A prism is just a three-dimensional shape with two like bases. So when we look at this one here, what we have is two triangles on top and bottom. So this is a right triangular prism. The top and bottom of this are going to be the exact same. The two shapes that are the exact same are the bases, and the sides that connect the bases are going to be called the lateral faces. And what we're going to do is when we find the surface area, and so what we'll do is we'll find the area of each of the different faces and add them all together. So for most prisms, what we can do is find the lateral area, which is going to be the perimeter times the height. Because if we take this prism here and each one of those different faces and put them right next to each other, we actually just get a rectangle. Because for most prisms, the lateral faces will be a rectangle. And then it just leaves us with our two bases. And we take whatever those areas are and add them together. So when we look at this here, this first one here, what we have is a regular right pentagonal prism, a right pentagonal prism. So if we want to find the surface area, we're going to find the area of the top and bottom, the area of these two bases, and then we're going to find the areas of all the lateral faces. So when we look at the areas of our top and bottom, well, they are a polygon. The area formula for a polygon is 1/2 the apothem times the side length times the number of sides. So when we look at this here, well, our apothem, I did give that to you, is 4.854. Our side length is told to us to be 7.05. And the number of sides is 5. So if we want to calculate this here, we can plug all these numbers into the calculator and work this out. Apothem is the length of the line going from the center of the polygon to the edge and forms a right angle. So it's almost like a radius kind of.
So like that thing?
So for this shape here, if we talk about for a triangle, it would be from this middle of the triangle to the edge and makes a right angle.
Okay.
So for this shape here, it'd be this length here. It'd be the apothem. So I'm giving the apothem to you, and for all the homework problems, I will give you the apothem, the height, what you need to be able to solve the problems. And if we type all this into the calculator, we see that the area is going to be 85.55. So the area for one of these pentagons is 85.55. Any questions on this here so far? Well, how many of these pentagons do we have? Two of them. We have a top and a bottom. So since we have two of them, so for our overall surface area, we'll have 85.55. And we're going to add to it 85.55. Because this is going to be part of the overall surface area. Because that gives us the top and bottom of this shape. And the last thing we need to find is the lateral faces. So any questions on how we found the surface area of the top and bottom? Now the lateral faces for this here, we have multiple different rectangles. And we actually have 5 of them because we have 1, 2, 3, 4, 5 different lateral faces. And we kind of also get this from the fact that it is a pentagon. Pentagon has 5 sides. So if we have 2 pentagonals on top and bottom, to connect the 2, we need 5 different lateral faces. Questions on how this works or anything of this here so far? Now when we look at this here, well, we know that the height of each one of these is going to be 9 because each one of these is coming from this here, and we're told that each side is 9 feet tall. Now we also know that each side length here is 7.05. So now we just need to find the area of this here. Now each one of these individually is a rectangle. The area formula for a rectangle is length times width, yes? Well, don't all these really combine together to make one big rectangle? So this here is just a big rectangle, because if we put them all together, it's one rectangle. So we can either find the area of each one of these and add them all together, or we can add all of these lengths together and multiply it by 9 because it's one rectangle. And if we add them all together, 7, 14, 1, 28, 35, we get 35.25. And we can multiply that by 9. And if we multiply that by 9, we get if we multiply these two together, we get 290.25. Any questions on any of this here so far? Yes? What'd you get?
I got 317.25.
317.25. Thank you. Yep, that seems better. Yep, I did 32 instead of 35. Yep. Any questions on how we got any of this here so far? So, I'm going to erase this here. So we look at the surface area of these shapes. The area of the top and bottom was our 85.55 because we found the area of the top and bottom, how much space it's taking up. Then we found the area of the lateral faces. And to find the overall surface area, we add all of these together to find the overall surface area, how much space the overall object has, or how much it covers if we were to wrap this. And we can add these together. 5, 5, and 5 is 5. Here the 1. 5 and 5 is 10. Plus 2, 3. 3, carry the 1. 5 and 5 is 10, and we get 8. 16. 8 and 8 is 16. Yep. So the surface area for this here is 488.35, and it would be feet squared if we were talking about the units. Any questions on this here? And so really when we're talking about surface area, we're talking about the area of the entire shape if we were covering it. So if you're talking about like wrapping paper, wrapping a present, how much paper would we need? How many square feet of paper do we need to wrap an entire box or shape? That's surface area. How much of the surface do we have? questions on this here? Now, prisms is going to be one of the ones that's the most tedious to find the surface area for, because we're really having to find the area of each of the different sides. Any questions on this here before we move on to the next thing, or the next problem? Now, this next one that we have here is a right triangular prism, or just a triangular prism. It's not right because it is not a right triangle. Because if one of the bases, or both the bases are right triangles, then it would be a right triangular prism. We name it based off the bases, because it has 4 rectangular or square sides. It is considered to be a prism, and since the 2 bases are both triangles, it's a triangular prism. Yes, well, it'd be the sides that are the same. Because we have 2 triangles, those are the bases. Now, if they were both squares, then it would be a rectangular prism or a square prism. We could also have cubes, because that's all the sides are squares and the bases are squares. It would be a cube. Any other questions? So what we need to find is the area of the bases and the area of the lateral faces. So since we said the bases are triangles, well, the area formula for a triangle is 1/2 base times the height. Well, our base in our case is what? 6. Because these little hash marks on pretty much every single side, we have those are saying that all the sides are the exact same. And they give us a unit of 6, so all the sides lengths are going to be 6. Now, I went on and gave you the height of the triangle. 3 square root of 3. I'm not going to make you go through the process of actually finding what the height is. So the height of the triangle is 3 square root of 3. So if we want to find out what the area of one of the bases is, we just need to multiply these together. So we can do 1/2 times 6 times 3 square root of 3, and see that this here is 9 square root of 3. Any questions on how we got the area for the triangle?
Does this formula only work for rectangular, triangular prisms?
So that 1/2 base times height is for triangles, is the area formula for a triangle. So we found the area of this base, so the triangle. So for triangular prisms, we'll use this to find the area of the bases. Yes. Well, how many of them do we have? Well, we have 2 of them, so we'll need to add it to itself. So those covers the top and bottom. Any questions on how we found the surface area of the top and bottom of this shape? Now, the lateral faces, we're trying to find the area of each one of these sides. Now, for the area of our lateral faces, what we can use is the height times the perimeter. And this works for any polygon. And we had this formula at the beginning, and we could have really used this to begin with. Now, when we look at this here, the height for each one of these rectangles is going to be what? 6, because we're talking about how long is it? It's 6. Now, the perimeter, there we go. And I'll use a different color here, say teal. Nope, that's not going to show up. Let's use that color. It's going to be the area, or kind of the perimeter around the triangle. the overall length of all those rectangular faces. Well, we have what? 6, and 6 is? What 6 is? 18. So the perimeter is 18. And at this point here, we can do 6 times 18, and we can do that straight in the calculator. And 6 times 18 is? So the area of all the sides of it is 108. Any questions on this here? Well, we'll have to add that to our two others. So if we want to find the surface area, we add all of these three together. So we add the 9 squared root of 3 plus 9 squared root of 3 plus 108. And if we add all these together, we get and I think it'd probably tell you it's 108 plus 9 squared root of 3. Or if we convert it to a decimal, what do we get? Either one of those will work. Now, if it's asking you, especially on Big Ideas Math, to round to the nearest 10th, 100th, or 1000th to a decimal place, we want it as a decimal. We'll want this here. But on the test, I will take either one of these because they're the same number. They're the same thing, just written in a different form. Any questions on any of this here? Any questions over anything we've done so far? If we're good with this here, let's look at the next one. Okay, so find the lateral area and surface area of a right rectangular prism with a height of 7 inches, a length of 3 inches, and a width of 4. So it asks for two things. It asks for the actual surface area and the lateral area. Now, when we look at this shape here, we do have this top piece, which is 4 by 3. We have this bottom piece, which is 3 by 4 or 4 by 3 also. So those two are the exact same. So that would be considered our rectangles, why we call it a rectangular prism. The lateral faces are all the other sides. So, almost got that one. These four here would be considered the lateral faces, the lateral area. So when it asks for the lateral area, it's wanting those there. And if we want the overall surface area, we have to add all of those areas together to get the surface area, how much space it's covering. So our surface area. Now the area of the bases, well, this is a rectangle. How do you know where the bases are? This one here, really, it doesn't matter which, because the two sides are the exact same. They're both rectangles, so it's a rectangular prism. The top and bottom of it are both rectangles, so it's a rectangular prism. The front and back of it are both rectangles, so it's technically a rectangular prism. So we're really looking to see which two have the exact same side. Now with this one here, okay, both of those triangles are the exact same, so it's a triangular prism. We need two that are the exact same, and they're normally opposite each other. They don't touch. So the fact that it does have three rectangles is kind of helpful, but since they all are touching, they share an edge, a line edge, but they wouldn't be considered our bases. Two bases don't share a common side. With this here, so no matter how we rotate a rectangular prism, it's still going to be considered the bases. So it's really dealer's choice of what we pick is what the bases would be, because it's still going to work out the exact same. If we picked these two here as being the bases and the other lateral faces, we'll still get the same answer no matter how we set this up. We just have to pick which bases we want it to be. Does that make sense?
Yeah.
Now for this here, I'm going to pick the top and bottom, which is 3 by 4. And the area formula for its length times width, which will be 3 times 4, which is 12. So the two bases, the area of those two bases is 12 and 12. Any questions on this here?
How'd you get the one that says A equals?
A equals LW.
Yeah.
Area equals length times width. Because length and width is our area formula for a rectangle. So we have the top and bottoms areas. Now we need the lateral faces all the way wrapping around. Now the way we can find this is the height times the perimeter. So we're looking at all these boxes we drew in red. Well, what's the overall height of it? How tall are they? 7. Because when we look at any of these boxes, the back one or the one over here, the one number that they have in common would be the height. And all 4 of those have a common number of 7 because they're all 7 tall. Yes? Now the perimeter is going all the way around. So I have 3, 4, 3, 4. Yes? Because perimeter is just walking around the overall shape. So a length of 3. So we can write that out. 3 plus 4 plus 3 plus 4. Well, 3 plus 4 is 7 plus 3 is 10 plus 4 is 14. We agree with that? So to find its overall area for all these sides, we do 7 times 14, which is 98. Yes. So part of the answer for this here is 98 because that's our area for lateral faces. It asked for that. Because the area of the lateral faces is 98. Now to find the surface area, we just have to add 98, 12, and 12, all those areas together. Zero, carry the 1. I think it should be 122. It'd be inches squared if we were to include units. Because 98 and 12, how I would look at it, because I know 98 plus the 2 is 100, and the 10 gives us 110. And our 110 and 12 would give us 122. I put it together by parts. Any questions on any of this here? Are we good with this here so far? Yes.
I don't know how to ask a question.
So a lot of what we're doing with this here, really, if we look at this box, so as we considered at the top, you have this face. Because if I broke this up and just cut it along its edges, it would look like this, yes? Because y'all have taken a box and completely flattened it out. And what we've done is pretty much the area, we can call this the top and bottom. As we said, it was 3 by 4, 4, 3, 4, 3, 3, 4. 7, 7, 7, 7, 7. This would be 3, 4, 4. Because these are just our lengths. And what we pretty much did is found the area of each one of them and added all together. So really that's what we're looking at, just in a 3-dimensional form. So really surface area is helpful because it tells us pretty much how much material are we using for this here. Does that kind of make sense? Any other questions on this here? Now, surface area of a right cone actually does have a formula for us. So for a right cone, surface area is equal to, well, our lateral areas, because if we take a right cone and cut it, it actually comes out to be a rectangle. So you can do this with a can, just be careful because tin is sharp. But if you cut the lid of it and the bottom of it off and went down the side and flattened it out, it would actually make a rectangle. We would actually get a rectangle, and its area is going to be 2 pi RH. And this is our lateral. Plus, well, the top and bottom are both circles, and the area of a circle is pi r squared. And we have how many of them? 2. So really we can say plus 2 pi r squared. And this formula here will actually give us the surface area of any right cone, or not right cone, right cylinder. Now, we really didn't have a set formula for most prisms because, as we saw with the 3 we did, the area of the bases changed per each one that we did, but the overall lateral faces didn't. So the area of the bases really changed from 1 to 1. But for a right cylinder, by definition has circular bases. If we have circular bases, most likely we're talking about a cylinder. Now with cylinders, we really are just going to end up filling this formula in. So when we look at this here, what is the radius of this cylinder? 4. So both of the spots where there's an R, we're going to fill in 4. And now what would the height be? 8, because it says it's 8 meters tall. And now what do we need to do to find the area, surface area? Plug it all in. Type all this into the calculator, because it'll do it for you. We don't have to do this by hand. Here's what? 96 pi. Because if we did this 4 times 8, 8 and 8 is 16, 32, times 2 is 64 pi. 4 squared is 16, times 2 is 32 pi, which does add together to give us 96 pi. And again, if the homework is asking you to round to the nearest tenths, hundredths, thousandths, we do have to approximate pi, because pi is a number. It's 3.1415926, going on and on and on, and there's people who have memorized it to hundreds of thousands of places. Whatever fits your fancy. I don't see the point of it, but you can do it if you want. So do you have 96 pi in the calculator? Do you see the button that's above it that looks like 2 arrows? If you click it and hit enter, possibly, we get 301.592. Would be that there. The 2 little arrows above enter. Yep, so that changes it from decimal to fraction or fraction to decimal. So it'll go either direction. Any questions on this here? You like cylinders? So if we're going to the nearest thousandths, tenths, hundredths, thousandths, we would look at the one after the 2. If we're going to the nearest hundredth, so I'd look at the 2, which tells me to round down, which would just be 0.59, 0.59. Now, if it had been, I'm just going to rewrite this, because I know it's not, it is 2, but let's say it was 5 or above, because this would be 301 point, because we round up, so the 9 would become 60. It's going to want 0.60. And we leave the 0 as a way to say that we rounded. Because if we round and it becomes 0, we need to leave it because it is a significant figure. It's a significant number. So on some of them, if you round it up, left it off, there's a good chance it would have marked it wrong because it needs that 0. It's going to be particular about that. Questions on this here? Okay. 2 pi RH plus 2 pi R squared. So we look at this here. What is the radius? 2. The height is 2 pi times 2 squared. Yes. Right. 133. 153. Point. Okay. 153. 153. Okay. I'll get there eventually. Questions on this here? Any questions over anything we've done so far? We're good with these here? Okay. Similar solids. Now, we talked about similar triangles in previous chapters where their scales are the same, because if they're similar, it just means that we're making them bigger or smaller. We're scaling them. So similar solids will have a similar scale factor. The sides are going to be scaled proportionately. So if we look at this here, we're comparing them to cylinder A. The height and the radius, their proportions should be the same as one of these others if they are going to be similar to each other. So if we look at some figure A, cylinder A, so we could do 4 over 6 or 6 over 4. It really doesn't matter which way we set it up. Well, 4 over 6, will this reduce? What would 4 over 6 reduce to? 2/3. So if B or C, if we can plug those in and see that it reduces to the same thing, then they are similar. If it doesn't, then they're not. So if we look at cylinder B, well, I put height over radius, yes? So this one here, I would put height over radius. Well, 3 over 5 reduce. Well, no, we can plug it in a calculator and do 3 over 5 and see does that reduce, and it will just tell you it's 3/5. There's not a common factor between 3 and 5. So is cylinder A and B similar? No, because their scales are not the same. Well, now we have 5 over 7.5. And I'll tell you that this does reduce, because what is 5 over 7.5? And most likely it'll give you a decimal. And if we hit those 2 arrows, it'll convert it back to a fraction, which is 2/3, and I think as a decimal it's 0.6 repeated. So the one that is similar to cylinder A is cylinder C. Because as long as those side lengths are proportional to each other, then the two figures are proportional. Any questions on this here? Are you able to get it?
I got 0.6 repeated.
Mm-hmm. Do you see the little button above enter?
Yes.
Hit it.
Oh.
And it gives you 2/3. Mm-hmm. So if you want, you could actually convert them all from fractions to decimals and see, do their decimal answers match up? Because if they do, then they're similar. If they don't, then they're not. Questions on this here? Does anybody have a guess at which one it's going to be? Did cylinder B actually change? No, it's still 3 and 5. I noticed that earlier today, so if it has to be one of them, it's the one that actually changed, not the one that didn't. Because we knew that cylinder B didn't work the first time. Well, since cylinder A and cylinder B are the same, it's still not going to work. Now, the last thing we're going to look at is similar solids, finding the surface area. And this is the last thing we're going to actually look at. Now, again, we said with similar solids, they are still proportional. We're still scaling them the exact same way, yes? So, height of 6, height of 9. So which one are we trying to find? The surface area for prism A, yes? So we want to know its surface area. And the one that we were given is 128 centimeters squared, yes? Surface area is always squared. I have squared units over squared units. Yes? Now, they told us the heights of each one. They told us one of them has a height of 9 and one of them has a height of 6, or a length of 6. Which unit would we put on top? Because which one are we trying to find? Prism A, yes? I put its surface area on top, so its length has to go on top as well, yes? 6 would be on bottom. So for surface area, we're dealing in what? Units squared, yes? The surface area is in units squared. Is our 9 and 6, are those in units squared? Because we're talking about the height of, or this length of 9 what? Centimeters, yes? This length is 6 centimeters. Surface area is in centimeters squared. So are the units really the same? No, because one of them is to the first, the other is to the second. If we want these to be proportional, we really need both of them to be to the second power, yes? So what we have to do is the 9 over 6, we have to square it. And this works with anything, because if we were actually talking about volume, volume is cubic. So if this was volume, we would have to cube that scale to get it to be the same. Now, we'll have x over 128 is equal to, well, we can do 9 over 6 in the calculator squared. Which I think it reduced it possibly. Or you might have got the answer. Mm-hmm. Yep. Because this will reduce to 9/4. Because 9/6 does have a common factor of 3. So it would reduce down to 3/2, which would be 9/4. Now to get x by itself, what do we have to do to both sides? Multiply both sides by 128 because we want those to cancel to get x by itself. So we have to take 9/4 times 128. So the surface area of our other shape is going to be 288, and it would be centimeters squared. Is 288 a number that we would expect to get? Is the prism getting bigger or smaller? Bigger, yes? So did the surface area get bigger? Yes. As if the If the shape gets bigger, the surface area should increase. If the shape gets smaller, the surface area should decrease. Questions on this here? Last one we'll look at today is this one here. So when we look at this here, trying to find surface area. They didn't tell us the surface area of prism B, so we'll call it X. The one that they did give us was 352. I always try to put X on top because it's a little bit easier to work with. So B is what we want. Its unit is 6. The one they gave us was 8. Is what? And that's squared. And if we squared, it should give us 9/16 if we plugged it in. Last but not least, what do we need to do? What is it? Well, the shape got smaller. Yes?
Multiplying the whole thing, like,
Do it.
16, or is just the numerator?
So it would be just the numerator, because we'll be doing 9 times 352 and then dividing it by 16. Now, because we can type it in that way 9 times. Y'all have a good rest of your day. We'll see you tomorrow. Your assignment is already posted. So what I was saying is because we can do that 9 times 352 divided by 16 if we wanted to do it step by step. As if we do this, 8 carry the 1, 6 carry the 4, 27, 31. If we multiply those together, we should get this, 3,168. Then we would divide it by 16. So we do 16 divided by 3,168. Well, it can't go into 30, it can go in 31 once, which would be 156. It goes into 156 9 times. 9 times 6 is 54. 9, 13. I don't think I did that right because 54. I wrote 45. 9. Yep. That makes a little more sense. Drop the 8. 118. It's going to go into it 8 times. 8 times 6 is 48. Or not 48. Let's see here. Yeah. 6 times 6 is 36, 42, 48. Yeah. And we get 0. So it works that way, and that's just for our fractions. We always multiply fractions by the numerator and then divide.